Hi, all of you. Good morning. क्या हुआ? Are we all alive? Yeah. Good morning, all of you. अच्छा लगता है ना सुन के. Good afternoon. Oh, that's why we're confused. Otherwise, you would have wished. I know. I tell my son sometimes, Indian parents are always, overwhelming. Standard instructions are uncle को नमस्ते बोलो, चुपचाप बैठो, ठीक है? So when my son was younger, ऐसे ही as usual lift में uncle को नमस्ते बोलो. My son told me, I don't like the uncle. Okay. So he got embarrassed by me telling, and he embarrassed me. Okay. उस दिन से I never tell anything now. Yes, all of you, good afternoon. So I think we have some of you who are starting the session of geography with me, right? So welcome, the cycle starts. What we do is, there are 3-4 entry points in geography which do not have much relationship with what is taught earlier. Like geomorphology has not much relationship with agriculture or population. Population does not have much relationship with physical geography. Climatology has almost no link with topics of geomorphology. So in these topics, we have some entry points. Okay, so that's how some of you have joined me for the new session of geography. So welcome all of you. Yeah, hi all of you online. Yes, hello, Avanish, Aman, Soumyadeep, Anu, Adish, Devraj, Shivali. I'm good. Ashutosh, I'm good. So I think some of you have seen the question paper of yesterday, and many of you are happy to hear truncated spurs, right? I think we had mentioned that in discussion. Okay, so it's just a chance factor. It's not that I was anticipating truncated spurs, they will ask, but we discussed what's interlocking spurs and how rivers will wind around those, and if the glaciers will cut through. Okay, so I had drawn this diagram also, where we have mountains, the rivers, they turn like this. These are winding rivers. The rivers are small, the rivers are not as powerful, तो घूम जाते हैं. But if there is a glacier, the glacier is a very powerful one. The glacier will not turn. The glacier will move straight like this. When this happens, this part of the spur will get eroded. This part gets eroded. This part gets eroded. So what you will have now is a landscape which has mountains with spurs truncated. Mountain with spurs truncated. Spurs truncated. Truncated means cut. And we have the glacier moving straight like this. So truncated spurs are evidences of glacial erosion. So I was telling this repeatedly that I'm anticipating a question on glacial cycle this time. And they did, but I didn't anticipate कि ये वाला पूछेगा. तो ठीक है. Okay, it happens sometimes. Okay, my wife also thought she'll marry a good, nice man. Okay, she got a good, nice man with some other package also. Okay, so I think you don't get everything in life. I'm not allowed to say anything about my wife because that will become sexist, and the feminists will take me for cleaning. Okay, so I'm okay being the villain here. Yeah? You need optional notes? You're asking the wrong person. Okay, you want optional notes? You must ask the piracy departments. For me, you're asking me to give my notes, which is my bread and butter. Okay. What do I do there? अच्छा ठीक है. How many pages to leave for remaining portions of geomorphology? Umang, maybe one class wala. So leave about 10-12 pages. That should be good enough. But आप लोग notebook में क्यों लिख रहे हो? अच्छा सभी लिख रहे notebooks में. Wow. I think you are in stage of your life where the first sign of maturity is don't write in notebooks anymore. Okay, ये पहला step है. You must write in loose sheets, which can be modified, pages can be added, pages can be removed, and once it is settled, then you spiral bind it. Okay, students say, sir, notes खो जाता है. Okay, ऐसे कैसे खो जाता है? अगर मेहनत किया है, okay, नहीं खोएगा. खोएगा when you know it's of no use. Okay, so my suggestion is this, but then, ठीक है, your call how you take it forward. 2 days holidays, okay, निधि, ठीक है. Once in a while, इधर उधर फैल जाता है. उसको बीमारी बोलते हैं. Okay, पेपर का नहीं, the person who is owning the papers. Okay, चलो, let's start off now. So geomorphology, I need one more session. I'll take up a session extra class में, not today. Today I have another class. So maybe tomorrow I'll take up some extra session. I'll let you know. It's almost done thereafter. Yes. And now we're starting with climatology. Climatology. This topic deals with atmospheres. It deals with the elements of weather, and it deals with weather processes. It deals with atmosphere. What does the atmosphere have? What gases? What are the constituents of atmosphere? How it behaves? Okay. And what are the elements of weather? Elements of weather means temperature, clouds, humidity, and precipitation. It includes winds and pressure. These are called as elements of weather: temperature, clouds, humidity and precipitation, winds and pressure. And then we have some phenomena, the processes. The processes how winds move, the processes how rainfall happens, the processes that leads to climate change. We have air masses as part of processes. So atmosphere, elements of weather, and weather processes. Some of you have joined me today. It will take you some time to understand work of art. Okay. I will be patient with all of you. Weather processes. So the mechanisms. Processes essentially means what are the mechanisms? Yes, that was the repeat question, correct. So geomorphology, the topic on mountain building. याद है आपका? What are mountain buildings and views? And what are the types of mountains? Block mountains, fold mountains, volcanic mountains. Yeah, so I'm happy you are familiar with that topic now. Acha, theek hai, let's come back here. So this is the scope of climatology. And they also have one more topic. Iske alawa, we also talk about the applied aspects. Applied, anything applied is related to how it relates with human beings, how it relates with agriculture planning, relates with urban planning, relates to dealing with pollution problems, relates with issues of climate change and consequences. The applied aspects are all related to planning, development, maybe problem solving. Okay, so these are all related to man. Applied aspects. Okay, so these are the broad 4 heads under which climatology is organized. Yeah, Rahul, good afternoon. Okay, so your reference book One is your NCRT. NCRT class 11th textbook on physical geography of the world. It's a good book. I think you must take time to read. There are 3-4 chapters in that. Okay, read that quickly if you can. This is a must read. This is a must read. Plus, Climatology of Savindra Singh. Climatology of Savindra Singh. Yeah, thank you. So this is the textbook, Climatology, and there are different editions. The cover page might look different, but the heading always reads Climatology. So some of you were bargaining with me about physical geography, isse kyun nahi kaam chalega. I hope you understood that once I have done the topic of geomorphology. Physical geography is one book which has geomorphology, climatology, oceanography, and also biogeography. Okay, so some topics of syllabus are missing here. Some topics are missing here. The physical geography, there's one compilation, all the top one book. My suggestion is don't buy this book. Okay, because there are some nuances beyond the regular topics which only the specialized books have. Okay, so buy this. In totality, you need to buy 9 or 10 textbooks in geography, and that's fine. Okay, एक पूरा 500 mark का subject है. It's okay buying a couple of books for that. So, Climatology, Savindra Singh. Achha. Now, apart from this, some of you have asked me from where to do the current affairs. So, in geomorphology, we don't have too much of current affairs, though we do have landslides. We do know a bit about volcanic eruptions and earthquakes. Okay, but climate topics, climate and environment, ये दो topic related है. There's a lot of current affairs in this. So one of you asked me, sir, do we need to look at down to earth? I said, yes, you can. There are other resources also, but my recommendation is don't spread yourself in these books, because there is one summary that we post every 15 days. Many of you are aware of that. Every 15 days, fortnightly, on your dashboard, on your website rather, website Edukemy, there is a resource section. In the resource section, go to current affairs. There we have the current affairs of geography and environment. In that, we look into all these publications. Okay, current affairs of geography and environment. It's on the website. There is a resource section. In the resource section, look at current affairs, geography and environment. This used to be one document that we called as the Cosmos. Okay, but now we are using this term directly on the website. This is all together. Okay, all together. The new students are part of the older batch also. No worries. Okay? So you guys can all refer to this one. Don't look into any other book beyond this for current affairs. Interest hai, to theek hai. You can look into a couple of these books like Down to Earth, but go with this. Yes, Abhijit, absolutely. Okay? So that's our reference books. And like geomorphology, this unit also has definitely 1 or 2 questions in the paper 1. And there are 5 topics: agriculture, there are topics related to soil issues, the topics related to vegetation, okay, and biogeography, topics related to disasters like floods and droughts, and even topics related to urbanization and land management. You will require topics of climatology. Muskan, yes, we had a shift of date. The IR topic will start from Thursday. We had taught from Monday, okay, but we have some backlogs. We'll start from Thursday. I'll let you know, don't worry. All good here, all of you? Okay, so we are done with the initiation. Let's start off now. climatology. Okay, so the first point, the atmosphere, you keep writing as I speak. The atmosphere is an integral part of the Earth system. It is an integral part of the Earth system, the atmosphere. When we say Earth, most of us talk about Earth as in continents and oceans alone. Okay, so if this is the Earth here, so we say there are continents, there are mountains, there are oceans, there are mountains, there are plateaus. Okay, we see this as the Earth. Reality is, even the gas around the Earth, this also is part of our Earth. So always we refer to Earth atmosphere system as one entity together. So gases are not apart from the Earth. The atmosphere is integral part of the Earth's system. Now, the atmosphere, okay, it supports life. The atmosphere is responsible for a lot of climatic elements and processes. The atmosphere is one of the shields. It supports the Earth as a shield, and it protects the Earth. Okay, the atmosphere, it supports life. So you talk about respiration, you talk about photosynthesis. Okay, it's because of atmosphere. It supports life. It is part of all the atmospheric elements and also atmospheric processes. Like I said, rainfall. Okay, we talk about winds. We have what's called as a biogeochemical cycles. Carbon cycle hai. The nitrogen cycle we have phosphorus cycles. So it is part of climatic processes and climatic elements like rainfall, okay, like winds, okay, plus all the cycles. They are part of the climate aspects, carbon cycle and so on. And it shields the Earth. It protects the Earth from asteroids. It protects the Earth from meteor impact. Meteor impact. I hope you know this. When the rocks enter the atmosphere, they can burn away in the atmosphere because of friction. If the Earth had no atmosphere, those rocks would impact the Earth and cause some damage. So it shields the Earth from asteroids. It shields the Earth from meteors. Meteors are what? Those rocks in the outer space. Okay, the meteors. And therefore, it kind of protects the Earth. And the atmosphere is also important as a part of communication today. I hope you know this. Radio waves communication use certain ionosphere layers. Okay, so what is the importance of atmosphere? Okay, it supports life. It includes lot of climatic processes. It shields the Earth for impact of rocks, meteors, of the outer space, and it's also a part of the communication. So it deflects radio waves. There's a layer of atmosphere called as the ionosphere. The ionosphere is responsible for deflection of the radio waves. It also serves the purpose of communication, long distance communication. This is the important atmosphere in short. अच्छा, इसके अलावा एक बहुत important aspect है. Very important aspect is the atmosphere is one of the primary components of the Earth that regulates the planet's temperatures. Is one of the primary components of Earth. The atmosphere is one of the primary components of Earth that regulates the planet's temperature. Okay, we'll talk about that eventually. So if you know this, which is the hottest planet of our solar system? Anybody knows? Venus. Why? Although Venus is not closest to Earth, the sun. We have sun, then we have Mercury, then we have Venus, then we have Earth, then we have Mars, we have the rest. Okay, Mercury is the closest, but Mercury is not the hottest. Why? Because Mercury does not have an atmosphere. Okay, although if I'm not wrong, the side facing the sun in Mercury, it can be as much as more than 430 degrees centigrade. The other half, okay, which is away from sun, it can be as cold as, okay, less than minus 200 degrees centigrade. Okay, because no atmosphere. Whereas Venus, with a very dense atmosphere, it can trap more heat. It traps more heat, and the average of Venus is again more than 430 degrees centigrade. So ये जो heat mechanism है, the atmosphere is capable of absorbing the heat. The planet that does not have atmosphere, it will become hot and also lose temperature very fast. Okay, so Mercury has lot of extremes. Okay, Venus is the hottest because Venus has a very dense atmosphere. Venus has a very powerful greenhouse effect. I think you understand this term. Greenhouse effect is when the atmosphere can absorb the solar energy and it becomes very, very hot. Correct. Okay. So Venus, Earth has atmosphere, but not as dense. So average temperature of Earth is how much? About 14 to 16 degree is Earth's average temperature. Although the highest has been more than 50 centigrade, the least temperature has been less than minus 80 also. Okay, but on an average, Earth maintains a temperature of 14 to 16 degrees centigrade. Okay, why? Because Earth has an atmosphere. Again, the Mars does not have as dense atmosphere as Earth. So Mars also has a good range of temperatures. Okay, उसके बाद तो planets are all gaseous planets. Okay, Jupiter, Saturn, Uranus are very far away. So just know this, that atmosphere has a very important role in terms of regulating the temperature. The atmosphere regulates the temperature of the Earth. ठीक है, all of you? So all these facts to help you consolidate. लिख लो, अच्छी बात है, otherwise nobody will ask you as such. Okay, just know this, the Venus has maximum average temperatures because of a very powerful greenhouse effect. Is it okay, all of you? Anybody else? Any questions on this? Okay, so what is atmosphere? And what does the atmosphere do in terms of how it benefits us? Then, the atmosphere's origin. How was the atmosphere formed? Okay, what is the genesis of the Earth's atmosphere? The origin. We say, like any other part of the Earth, you talk about continents, you talk about oceans, you talk about life forms, none of them have formed by one single event. Life is a consequence of lot of events that includes evolution, and today we have the type of life forms we have. If you look at continents, continents have not been formed suddenly. Lot of events, a smaller continent, then bigger continent, they got destroyed, they got modified, and then we have the continent that we have. Similarly, the atmosphere is not a product of one event. Okay, like, write down, like any other component of the Earth, atmosphere, like any other component of the Earth, the atmosphere is a product of is the atmosphere is a product of many processes acting at different times. Many processes acting at different times of Earth's history. Different times of Earth's history. Okay. The atmosphere has evolved through many events. The atmosphere has evolved through many events. Okay? So it's not that one event made Earth's atmosphere. There are many events which have together made our Earth's atmosphere. So the oldest atmosphere, this was a product of what some of us might know, the process of nebular accretion. I think some of us know this. What is a nebula? Nebula is an ancient gas, ancient cloud. And this nebula was spinning, and the nebula became Earth. So when nebula became Earth, the heavy, dense particles became the core. And progressively outside, the lighter elements remained. The gases were the lightest, and they became the outermost part of the Earth. If you look at the Earth, Earth is layered. Earth has layers. The innermost layer is the core of the Earth. Then we have different parts of mantle. The outermost layer of the Earth is something called as the crust. Beyond the crust, we have the gases. So this was one process how the atmosphere was created. There are two lines in this. The oldest atmosphere is the result of nebular accretion. Let down, continue. The atmosphere with its gases, was the outermost layer. With its gases was the outermost layer. I think some of you know this term called as gravity collapse. Yaad aa raha hai? Okay. What does gravity collapse mean? That when a gaseous mass is becoming solid, the heavier ones will be inside at the deeper parts, and the lighter ones will remain outside. So this is the densest, a bit less dense, a bit less dense, the lighter crust, and the lightest are the gases. So the atmosphere was part of the nebular accretion process. But then remember that this nebula, it must have formed, okay, the atmosphere mostly composed of hydrogen and helium. ये oldest atmosphere था. It was the oldest atmosphere. The outer layers were hydrogen gases and helium gases. And these are very light. They are very light. They must have escaped. So this old atmosphere is no longer there with us today. Some traces of helium remains. It's a very negligible part, but it has now escaped. Traces of hydrogen remains. Much of hydrogen has again escaped. Okay, this was the oldest atmosphere. Then what happened was, okay, the atmosphere impacted by the tectonic process. Tectonic process का मतलब होता है volcanism is happening. Lot of gases came out from the Earth's interiors. So whenever there is volcanic eruption, it is not just gases, it's just not molten rocks coming out, not just lava coming out. What comes out is carbon dioxide, what comes out is water vapor, what comes out is sulfur compounds, nitrogen compounds come out. So the atmosphere later was the product of tectonic processes like volcanism. इससे क्या बना? This process gave us carbon dioxide. This gave us our water vapor. It gave us the nitrogen gas compounds. It also gave us the sulfur gases. Okay. Most of the water vapor, it rained. It rained down. It has now become the water of the oceans. A question बनता है कि from where has the water of the oceans come? Some say the ocean water has come from outer space. But now we know whatever we have as water has come from the interiors of Earth. Some chemical reactions, some volcanism, the water came out, and that water vapor condensed and fell down as rain, and that has now become the water of the oceans. The carbon dioxide, most of it has been washed down with the water. Okay, the CO2 that the atmosphere has is a very small part. Bulk of the carbon dioxide has washed down in the oceans. That's why lot of carbon dioxide, okay, so a lot of carbon dioxide remains dissolved in the ocean waters. But some carbon dioxide is still there in the atmosphere. Okay, nitrogen sulfur compounds, they continue to remain. They remain in the atmosphere largely. So atmosphere mein nitrogen is a very big amount that we have, largely from the volcanic process. This volcanic process is also called as the process of outgassing. Is also called as the process of degassing of the earth. So how was our atmosphere formed? Partly from the nebular process. The nebula was cooling, contracting, and the gases remained outside, but those gases have escaped. Then atmosphere was impacted by the tectonic processes. Volcanism was very important. Volcanism gave us our carbon dioxide, it gave us nitrogen compounds, it gave us water vapor, and even sulfur compounds. Some of these are still in the atmosphere, but some of these have washed down, have become part of the oceans. So this is a very important part of the atmosphere's formation, the degassing process or the outgassing process. And the third process is the biological processes. Biological processes has given us carbon dioxide. It has also given us some amount of water vapor and has given us oxygen. Carbon dioxide, water vapor, these come from respiration, and this comes from photosynthesis. It comes from photosynthesis. Okay. Apart from this, the atmospheric composition has also been modified by a human interference. Okay. So what has man done? Man has added lot of pollutants. Atmospheric composition has also been modified by the human interference. So when I say human interference, this is not natural. We are tampering. So we have added pollutants, we have increased carbon dioxide, okay. We have also destroyed some bit of ozone, okay. So pollutants we have added carbon monoxide. ये present naturally नहीं है. Okay, pollutants, think of chlorofluorocarbons or hydrochlorofluorocarbons. These are not natural components. We have added those in the atmosphere. Lot of pollutants also includes lot of dust also. Okay, so the 4 processes which has given us the atmosphere of today: the nebular process, the tectonic process of degassing, the biological processes of respiration and also photosynthesis, and some processes where man has tampered with the atmospheric composition. So this man's impact is responsible for some of the unfortunate climate change events that we have today. Pollutants, I said, carbon monoxide is a pollutant because of incomplete incombustion, carbon monoxide. Chlorofluorocarbons, CFCs. Okay, we have hydrogen component also. So hydrochlorofluorocarbons, HCFCs. A lot of variants on this. Okay, and we have added more CO2 also. Plus, we also have destroyed a lot of ozone. Ozone destruction is also part of modifying the atmosphere's composition. And the 5th aspect is, now, इस सब में जुड़ा हुआ है. Atmosphere is also impacted by the chemical reactions within the atmosphere. The chemical reactions keep happening. One example of chemical reaction is how is ozone formed. Oxygen with a nascent oxygen forms ozone. The ozone will again break up into oxygen and nascent one. It again forms ozone. The cycle goes on. Okay. The chemical processes or chemical reactions, they also impact the atmospheric composition. One example of which is the formation and destruction of ozone continuously. Yeah, ozone, it's a continuous process. Ozone is formed, then ozone breaks up, again ozone is formed, again ozone breaks up. In fact, you can know this, that this process is called as Chapman cycle. It's called as Chapman's cycle. The formation and the repeated destruction of ozone. There's a balance by which it is maintained. But again, man has impacted that. All fine here? So what is atmosphere? What does atmosphere have? Okay. What is the origin of the atmosphere? And what is the importance of the atmosphere? So none of this I see as a straight question, although they can ask. The way UPSC is twisting the questions, they can ask, but I think you should know these terms and use it where convenient, rather than waiting for a straight question to be asked. All good here? Way point chuta? Anybody has missed out any point? Ask me, I'll clarify if required. Can I move on? All good? Online, offline? Okay, ठीक है. Let's start off now. Now this is where we enter the course slowly. What is the composition of atmosphere? What is the composition of atmosphere? So we know how the atmosphere must have been formed. Chemical processes, biological processes, tectonic processes, and so on. So ultimately, all the processes together, okay, what's the composition? Priscilla, what's the doubt here? Accretion. What's the accretion and what's the meaning of gravity collapse? Okay, fine. Okay, I understand. Some of you have not done those topics. So what happens is, initially, I mean, this is a theory. We do not exactly know how the planets are formed, how the stars have been formed, how the solar system has been formed. So there are many theories. One theory you know called as the Big Bang theory. I think all of us have heard that. That's one of the theories. But then there is another theory also. It's called as the theory of a nebular accretion. Nebular accretion was given by two people. The first one was given by a man called Kant, a German scholar. There were some mistakes in this. It was modified by one more man called as Laplace. The Laplace concept is more closer to what we know today. So what they're saying is that this nebula is essentially a cloud. It's an amorphous, shapeless cloud. A cloud that has gases, a cloud that has lot of dust. So it's lot of particles like this, all scattered, no form, no proper shape. Okay, and this is also rotating, spinning. As this nebula spins, it becomes cooler and it starts to shrinking. The shrinking of nebula and it becoming solid is what's called as nebular accretion. का मतलब होता है growth. Okay, growth of a solid accretion. Okay, हिंदी में जम गया. Okay, it is a kind of becoming solid. So this nebular accretion process is about how the gases, okay, which were shapeless, they start to cool down, they start to shrink, and they become solid. So when they become solid, this solidification, this is what is called as accretion. This happens because of gravity collapse. It happens because of gravity collapse. So in gravity collapse, what happens is the heaviest material, the densest material will form and collapse towards the center, and the lighter ones will remain outside. So the densest one becomes the core, a bit less dense becomes part of some mantle, a bit less dense becomes part of another outer mantle. Then you have a very thin layer which is very, very light, it's called as the crust. And the lightest ones are gases which remain outside the surface but bound by the gravity of the earth. So this layering, okay, this density layering jo hai, this is what is the consequence of gravity collapse. The heaviest one is attracted inside because of gravity, a bit less dense, and the lightest ones remain outside. This process is called as the gravity collapse. Check all of you. Anybody else? Chapman cycle is a process how ozone is created and ozone gets destroyed. The cycle is called as Chapman cycle, and human factors have modified the Chapman cycle also. Okay? Fine. Some of you are curious about this. Okay? No issues. We move on towards the composition of the atmosphere. Now, in the composition, remember, our atmosphere includes dust particles, it also includes gases, it also has moisture, it also has ions. Okay, so atmosphere ka composition jo hai, it is a very complex. Okay, atmosphere includes dust particles. When I say atmosphere, I don't mean gases alone. I also mean the dust particles. I also include moisture, water vapor, alag se pakdo, and also ions. Together are the composition. Now, in this composition, there are certain permanent gases whose composition does not change. The gases remain permanent. And then there are certain variable components also. जैसे कि dust particles are variable, such as water vapor is also variable. And the permanent ones largely include nitrogen, oxygen, argon, and also includes carbon dioxide, plus gases like you have got helium, you also have some amount of ozone, you also have some amount of neon. All of these are a very small amount, but very valuable. So these are also referred to as the minor constituents, and they are permanent. So if you look at your atmosphere, the atmosphere has permanent gases. I'm excluding dust particles from permanent because the amount of dust particle varies. In some places more, in some places less. There are permanent gases: nitrogen, oxygen, argon, and these carbon dioxide. These four are the major gases. Major gases, and they are more permanent. Of course, what you see as changes is because of human aspects. Human aspects has changed the amount of carbon dioxide, not naturally. Man has changed the amount of ozone layer. Otherwise, these are permanent. Permanent, and they are among the larger ones. And then I said gases like neon, gases like helium, gases like ozone, they are permanent but very less. We simply call them as the minor constituents of the atmosphere. And then we have the variable ones. Dust and water vapor are the main variable components of the atmosphere. Now, the all of you? All done? Okay. Now, ये जो major gases हैं, the major gases, they obey a concept called as major bolo, या even for that matter the permanent ones. The major gases and the permanent gases जो हैं, they obey a principle called as the principle of constant proportion. They obey a principle called as the principle of constant proportion, which basically means that the ratio of the gases, as a percentage of a dry air is fixed. The ratio of the gases as a percentage of the dry air is fixed. A percentage ratio doesn't change. It's like if I have a class, where there are three type of people, X, Y, Z people, the ratio remains same. X is always 30%, Y is always say 50%, and Z is always 20%. Doesn't matter how many people. Agar 10 log hain, the next will be 3 people, Y will be 5 people, Z will be 2 people. Agar 100 log hain, X will be 30, Y will be 50, and Z will be 20. If there are 1000 people, the same ratio, X will be 300, Y will be 500, and Z will be 200. The ratio remains same. Whether you have more people or less people, the relative proportion is constant. That's what it means. The major gases and the permanent gases, the way they mix, the mixing is absolutely constant, unless of course human factors is changing those. So I think you all know about the ratio. How much of nitrogen do we have in the atmosphere? Anybody knows? 70? 78 point something, but 78% is nitrogen. How much of oxygen we have? 21%. How much of argon we have? 0.99395, so 93%. Carbon dioxide is 0.03%. And the minor gases mein, you can take up helium, or you take up hydrogen, 0.000. Okay, 3 zeros, kahin 1, 5, 6, 0, 3% approximately each. If you take ozone, is 0.1, 2, 3, 4, either 4 or 5, whatever. This is the ratio of the bulk of the gases. Nitrogen, oxygen, argon. So you must definitely remember these four. And if you can add, okay, helium, you can also add neon here. Okay, this is each. And I'm saying approximately. किसी में 1 लगेगा, किसी में 4 लगेगा, किसी में 5 लगेगा. So 3 zeros, 3 I remember, and 4 zeros, 5. या इसको 4 कर लो. Okay, 4 zeros and 4, 3 zeros and 3. Okay, this is the proportion of the atmosphere in general. And this is proportion of what? This is proportion of gases in what? In dry air. A proportion is in terms of what? Weight or volume? This is what? In volume, remember. The proportion of volume of gases in dry air. It's not a ratio of the mass in terms of volume. Okay? These are the points where you can make a mistake in MCQs. What is the proportion of gases by volume of dry air? The water vapor, we don't, because water vapor, okay, water vapor is one of the most variable gases, okay, or components, water vapor. It can vary a lot. Dry air will have less vapor, moist air can have more vapor. Take all of you. What does dry air mean? Dry air means I'm excluding water vapor in the air. Usko hata do aap. You remove that and tell us how much of gases we have by volume of dry air. Okay, I'm ignoring water vapor. Water vapor is a variable gas. It varies. The lower layers more, upper layers less. Desert it is less. Wind, it's wet regions it's a bit more. Mountain top it will be less. Along the coast it will be more. Polar areas become less. So it varies according locations. But otherwise, these 5-6 of them, inka ratio constant hai. Why? Whenever I write this word principle, okay, there is no why. Yahi hai answer for many other things. There's no why. This is the rule of nature. The principle of gravity, the principle of inertia, the principles of thermodynamics. We don't ask why. The principle of optics, laws of reflection. Okay. So whenever I have principle, they are almost like laws. Ye laws mein why nahi puchenge. We just accept it, that's how it is. Okay? Some of you know, na? Isostasy as a principle now. We don't ask why it's there. That's how it is. That's how the earth balances. What are the 4 gases called? आप क्या नाम देना चाहते हो दे दो अभिजीत gases. Permanent gases. Permanent and the major gases. There's no other name for this as such. ठीक है? Anybody else? Okay, so atmosphere has, what are the 4 gases called? I think you typed that a mistake again. I'll ignore. Okay, they are permanent and the major gases, and we also have the permanent and the minor gases. Achha. Now, one question I ask in every class, and I'm surprised about how few people know this. When I study climatology, when I study climates, we say, although atmosphere has so many gases, the most important gases that we need to know and study are carbon dioxide and maybe ozone and maybe water vapor and maybe some amount of dust. ये add करे देखो 99.9, right? ये तीन मिला कितना हो गया? 99.9% हो गया, right? 99.9% of the atmosphere composition has no role to play or very less role to play in the climatic processes. Why? हाँ, हम किस बारे में कंसर्न है आज के डेट में? कार्बन डाइऑक्साइड, राइट? बिकम कार्बन न्यूट्रल, decarbonation processes, that we have to reduce emissions. Emissions में क्या हटा दे रहे हो? कार्बन मोनोऑक्साइड में भी, reduce water vapor में भी, reduce CO2 में भी, reduce sulfur compounds में भी. We don't talk about nitrogen, oxygen and argon, do we? Okay, so 99.9% of the atmosphere has almost no role to play or very minute role to play in atmospheric processes. Why? Anyone knows the answer? Yeah? Yes. Yes. Anybody else? Yes. नहीं, ये तो इनर्ट नहीं, इनर्ट तो बस यही है और ये वाला, ये इनर्ट थोड़ी है. Yes, some of you got it. It's because okay, these are not greenhouse gases. What's a greenhouse substance? Anything that absorbs heat energy of the sun or energy in general. So whatever atmospheric process we have, why do winds move? Why does air rise? Why do clouds form? Why do we have rainfall? Okay. For that matter, why do even ocean currents move? All the dynamism of the oceans or the atmosphere is primarily linked to difference of energy. Tropics are hotter, okay, they will rise, air will rise. The polar areas are cooler, the air will sink. The air then moves towards the polar areas and the air starts circulating. Low pressure areas are areas which have warm conditions, air will rise. High pressure areas which have cold air will sink. It is temperature variations, okay, and variations in the energy distribution which is mainly responsible for why we have the atmosphere and even ocean dynamism. Okay, and this difference of temperature or heat is because of the heat absorbing capacity of some of the constituents, which are carbon dioxide, which are ozone, water vapor, and the range of the pollutants. Carbon monoxide is also very effective in absorbing heat. Okay, pollutants like your chlorofluorocarbons also, they're very effective in absorbing heat. So anything that absorbs heat is the main reason why we will have some atmospheric processes. Now, I'm not saying ये तीन important नहीं है. Again, I need oxygen for life, respiration. I need nitrogen and argon for dilution of oxygen. Otherwise, oxygen is, okay, it will support combustion, right? The atmosphere will burn. So, nitrogen and argon, they are responsible for, okay, making the atmosphere diluted. Plus, some of us know how nitrogen can be trapped in the soil and it's used for plant growth. So, इनका भी importance है, but इनका importance in atmospheric processes में it's very, very less. The atmospheric processes are because of difference of heat energy and temperature at different locations of the earth. All good? There are 2 points here. Okay, write down that the atmospheric processes related to winds movement, the atmospheric processes related to winds movement, comma, precipitation, winds movement, precipitation, or phenomena like cyclones, are all related to differences in heat energy absorption, are all related to differences in heat energy absorption in the atmosphere. Next, the heating or cooling of the atmosphere, the heating or cooling of the atmosphere happens because of the greenhouse gases or greenhouse substances, anything. GHG बोल लो या GHS बोल लो, short forms we use. Greenhouse gases are GHGs or greenhouse substances, GHS. Some short forms are allowed, they're used because of greenhouse substances like carbon dioxide, like water vapor, like ozone, okay, dust particles, or even pollutants like carbon monoxide, methane. Methane atmosphere में है naturally, but very less. Okay, carbon monoxide is not in the atmosphere at all. Whatever carbon monoxide we have, it's because of the combustion, we burning fossil fuel. Atmosphere has a very small amount of methane. Okay, CH4 is methane gas. But we are adding methane again because of human activities. So carbon dioxide, ozone, water vapor, okay, you can add dust particles, you can add methane gases or synthetic gases like what does synthetic gas mean? What meaning of what synthetic का मतलब क्या है? Yeah, nobody? Artificially made, correct. Synthetic is man-made, yeah, lab-made, or okay, something which is not natural is synthetic. The synthetic substances like chlorofluorocarbons and hydrochlorofluorocarbons or hydrochlorocarbons, whatever. Okay, these are all synthetic material. They're not found in nature naturally. We have made them. Okay? So these are the greenhouse substances. Therefore, write down, therefore, 99.9% of the atmosphere, 99.9% of the atmosphere, okay, within bracket, nitrogen 78%, oxygen 21%, argon 0.93%, nitrogen 78%, oxygen 21%, and argon 0.93%, very closed, are directly not responsible for the atmospheric and climatic processes. The atmospheric and climatic processes. Is it okay, all of you? So that's one insight for all of you. Okay, so what is atmosphere? What does the atmosphere have? How was the atmosphere made? And what the importance of atmosphere in some ways. Okay, so the minor gases are more important than the major ones. Even the variable ones are more important than some of the permanent ones. Okay, I'm moving on now. Now we'll discuss, give a heading, structure and arrangement of atmosphere. Structure and arrangement of the atmosphere. These are very straight elementary discussions, whether it is GS or geography, optional, they are common. So some of you have been part of the geomorphology now, okay, from where I started slopes discussion, वहाँ से different from what GS is. In climatology, unfortunately, for most of you, and good for us at least, okay, the entire climatology is important for, okay, your GS. Maybe one part called as a climatic classification, they may not ask, okay, at least not the way the books have it. Otherwise, all topics of climatology are important for GS also. ठीक है, ये पूरा climatology पूरा important है. So structure means what? How is anything arranged internally? The structure of a building, the structure of human body, the structure of rocks. So from internally, what is it made up of? Internally, how are things arranged? What is Earth's structure? Arrangement कैसा है? Core, mantle, crust is the arrangement of the Earth. There's a structure of the Earth. The structure of a mountain, what type of rocks, what type of features within the mountains. So whenever you're asked this word structure, remember it's about the internal aspects of its composition and how the arrangement is. Okay. So atmosphere, so I have 2 points here. Atmosphere is a mixture of gases. Atmosphere is a mixture of gases. Okay. So I hope all of you understand what a mixture is and what is a compound. What happens in compound? The individual elements, okay, they combine together. Okay, so they combine and they become some kind of a new substance. Okay, in properties, the new substance is different from the original one, and in many cases you cannot separate them. In all cases, for example, you can't separate them using physical methods. Alag karna hoga, so you have to go by some chemical processes. In a mixture, the X, the Y, the Z, they remain together, and this is not a new substance because X property retained hai, Y property retained hai, Z property retained hai. In mixture, the constituents can be removed by using physical processes. So atmosphere is a mixture, it is not a compound. That's why nitrogen, oxygen, carbon dioxide, water vapor, or argon, or ozone, all of these can be separated. Okay. In a mixture, there is no one definite property. Mixtures properties can vary. Okay, write down these 2 points. Within bracket mention, I said atmosphere is a mixture. Within bracket mention. Okay, so the constituent gases and substances, retain their original properties. They retain their original properties. And can be separated. However, the mixing is so uniform. The mixing is so uniform that the atmosphere obeys. The principle of constant proportion. The atmosphere obeys the principle of constant proportion for much of its height. That's a very unique thing. The gases are mixed. The ratio of gas is fixed, whether there is more gas or less gas, whether it is near the Earth's surface or you go above. If we remove the variable ones are water vapor and dust particles, usko hata do aap. All the other gases have some kind of uniform ratio of mixing. That's one of the properties of the earth. Okay. Now when I say much of the earth ka matlab kya, atmosphere ka matlab kya hai? Anybody knows what is the height of atmosphere? This is sea level. What the height of atmosphere? And there are debates on this. Most say that the atmosphere ends and the space starts around 800 to 1000 kilometers from the sea level. Okay. Others say no, it's much lesser. It's up to about 100 kilometers or approximately 62 miles. Why? Because the fact is, the atmosphere slowly grades into outer space. ऐसा boundary पकड़ना मुश्किल है. Okay. But then some have decided that this looks like a more favorable one. Beyond this, the outer space is a bit different. Okay. And some believe this line. This line, if you have heard about, was called as the Kármán line. Kármán line is a very important boundary for aircrafts flying. They say if you cross Kármán line, okay, the atmosphere is so rarefied, the regular planes can't fly anymore. Because for planes to fly, they need air to pass, right? Okay. There must be thrust only when the air can be pushed. If the air is very, very less here, the regular planes can't fly. You need some other technologies here. Some of you heard about something called as ramjet technologies. The ramjet technologies, the rockets can go beyond the outer space and come back again. Okay, वो अलग चीज है. So, because of aviation laws or aviation requirements, some consider the boundary is this one. Others say no, it's as much as this. Nevertheless, I'm saying this, the ratio of constant proportion is not for the entire atmosphere. It happens for much of the lower part of within 100. Head down. Next, head down. The lower parts of atmosphere, within 80 kilometers, the lower part of atmosphere within 80 kilometers is called as homosphere. There is one layer called as the homosphere. Homosphere is within 80 kilometers. You may consider, okay, the Kármán line boundary also. But Kármán line technically is about or 62 miles. Homosphere का मतलब क्या होता है? The air is more homogeneously mixed. Okay, the air is more homogeneously mixed. And beyond 80 kilometers, it's called as the heterosphere. Homosphere में all the gases are well mixed. And there is no density segregation. In homosphere, what happens? All the gases are well mixed. When I say all gases, I'm ignoring the variable one. Usko chhod do aap. All the gases are well mixed and there is no density segregation. There is no density segregation. So for some of you, if you know this, what's the molecular weight of oxygen? It is 16 plus 16, 32. What's the molecular weight of nitrogen gas, N2? It is 14 plus 14, 28. What is the molecular weight of carbon dioxide? It is 12 plus 32, 44. Right? What is the molecular weight of water vapor? Okay, oxygen 16, water vapor is 2, 18. Right? If there was density segregation, the lower layer is made up of what then? Carbon dioxide. If the density would segregate, then in atmosphere, the lower layer would have carbon dioxide. You go above, I would have oxygen. You go above, I will have nitrogen. And I will not have ozone here. I will not have any water vapor here. I will not have any of the other particles here. This is what's called as a density segregation. In reality, we don't have this. In reality, all the gases are well mixed. Okay, if you look at the earth here, whether you take the air here, or here, or here, wherever you take, everywhere nitrogen is 78%, oxygen is 21%, okay, argon is 0.93%, and ozone is, ozone chal chhod dete hain isko, we have, yeah, and carbon dioxide is 0.03%. So gases are not segregated, they are very well mixed. Okay, all fine here? So homosphere is that layer, the layer where all the gases are well mixed, there is no density segregation. ये पे add करो, that the homosphere acts like one single unified gas. The homosphere acts like one single unified gas, obeying the gas laws. Obeying the gas laws. Have you heard about gas laws? Boyle's law, Charles' law, okay, Gay-Lussac's law, Avogadro's law. Some of you must have done this. PV is constant, P by V is constant, or P by T is constant, or V by T is constant, volume and temperature. Okay, we call those as gas laws. So gas law is possible because the atmosphere acts like one gas. It's a very unique thing. Okay, it is a mixture, but the mixing is so good, it acts like one single gas. But actually the atmosphere is several gases which are part of the mixture, and each gas retains its own properties. Okay, the lower layer is homosphere, the above layer is called as heterosphere. In heterosphere, the gases and the ions, they segregate out according to their weight. Heterosphere में अब layers बन जाते हैं of different type of gases. In heterosphere, the gases segregate out in terms of their weight. Okay, so if you look at this is the Earth's surface here, up to 80 kilometers, maybe 100 kilometers, you want the carbon line. This is called as the homosphere. Beyond homosphere, okay, is the heterosphere. In homosphere, all the gases are very well mixed. They act like one single gas. In the heterosphere, यहाँ पे layer बन जाता है. The lowermost layer is nitrogen. इसके ऊपर में you'll have atomic oxygen, then you will have helium, and then you have hydrogen gases. The nitrogen molecular weight is 28, heaviest. Oxygen atomic weight, atomic number, it is the atomics minus. This is 16. Okay, helium is 2, hydrogen is 1. So there is a weight segregation in the heterosphere. It is not very well mixed. Plus, of course, other things are also there. There is homosphere. The homosphere is more unified. The homosphere behaves like one single gas. And we have nitrogen, oxygen, okay, helium and hydrogen. He's asking, okay. So do we remember all of this? Yeah, hydrogen molecule becomes 4 and this becomes 2. ठीक है, वो लिख लो, कोई दिक्कत नहीं. Beta, whatever I teach here, it is not for quiz and curiosity. ठीक है? It is also not directly meant for entertainment. You have to remember this. Okay. So don't stop at understanding things. आपको इसको अप्लाई करना और बहुत एलिमेंट्री बेसिक है. It's just that आपने स्कूल में गड़बड़ किया था, अब पैसे देके दोबारा पढ़ रहे हो. And you don't understand this, दोबारा पैसे देके फिर एक और कोर्स ज्वाइन करोगे. So you have to remember these things. The very elementary, very basic. Okay, whether they ask or not, that's their choice. But you must have the ability of using it wherever you can. Okay? So yes, you have to remember these things. And how to remember? The only way is a repeated revision and repeated writing. The learning does not stop at listening to a lecture. Your first step hai, where you get familiar, you've heard something, and I know you will forget. The only way of remembering is revise repeatedly and write as many times as you can. That's where I insist on make your own summaries. Okay? The new guys, there is one disease I have. Okay? Which unfortunately is not a communicable disease. आराम से फैल नहीं रहा है. Okay? It's called as synopsis syndrome. Synopsis is a summary. Whatever I teach, you go back to your room and summarize that. Before you guys came to class, I was sitting with 10-15 students who gave their mains. Some of them turned up today to meet me. Yesterday was the last day of the mains optional paper, mains paper, optional wala. So they came to meet me and I asked all of them one question. Okay. Give me your experience. What did you experience? One. Number two, how would you do your preparation, okay, so that this mains could have been better? And all of them unanimously said this. Sir, only if we had done the foundation notes and memorized them well, okay, we would not struggle in the examination. So some of them had given 3 attempts because the first 2 attempts ऐਵੇਂ लिख के आ गए थे. So there is no escape here. Okay, some of you want easy way out. There is no easy way out. तो अभी शुरू किया है, कुछ नाम जान रहे हो. Okay, but you have to remember. And there's no magic formula other than revise it repeatedly. Okay. In fact, I was thinking that I'll call some of them here. They can share what they did wrong in their preparation. Okay, and what could have helped them better. Yes, you can call that Shabbir Sir's synopsis syndrome. ऐसे नाम आप दे चुके होगे यार, अभी don't tell me. Okay, you all have names for me. Okay, तो मैं अपना ही नाम दे देता हूँ. I'll leave it to you. ठीक है? अभी शुरू नहीं किया and you are so scared. याद रखना पड़ेगा क्या? The only other way is, there are 2 other ways of qualifying. या तो बापू का कनेक्शन है. Okay. He knows somebody in UPSC. He will manage it. अगर है तो use it. Don't tell the others. A connection है और use नहीं कर रहे हैं, disown your father. धिक्कार है, ऐसे क्यों बाप के घर में पैदा हुआ मैं. Second is, इतना ड्रामेटिक एंड इमोशनल चेहरा रखो कि आपका चेहरा देखते ही आ जाओ. ठीक है, मैंने हमसे रहा नहीं गया. अब आए हो तो साक्षात भगवान पधार रहे हैं. अगर वैसा है तो very good. Let me know, I'll go with you. Otherwise, regular mortal way, revise it. Okay. We're talking about the structure of the atmosphere. I said, if I look in terms of relative mixing of the gases, there are broadly two layers. The lower one is called as the homosphere. The upper layer is called as the heterosphere. The homosphere is very well mixed. The homosphere is like one unified gas that obeys all the gas laws. The homosphere, there is no molecular or atomic segregation. And remember, I'm talking about the major ones, not all the gases. Ozone will vary, water vapor will vary, dust particles will vary. The bigger ones, nitrogen, oxygen, argon, 9.9%, yeah, that's good amount. Okay? Homosphere. So 80 kilometers, or you may also use 100 if I look at the carbon line. Beyond this, heterosphere is not uniform, but बहुत कम atmosphere रह जाता है यहाँ पर, very less. Most of these gases are ionic form, in traces, and there are layers. All good here? All of you fine? Okay. So that's one type of structure. The arrangement in terms of relative mixing of the atmosphere. The second scheme, basically, how can I divide the class? I can divide the class in terms of gender, divide the class in terms of maybe the state you come from, divide the class in terms of what education background has been, okay, different ways. So how can you divide the atmosphere? You can divide the atmosphere on the basis of relative mixing. You can divide the atmosphere in terms of, I'll talk about the pressure patterns in the atmosphere. You can divide in terms of the temperature patterns of atmosphere. ये अलग-अलग schemes हैं. The second scheme is the atmospheric structure on the basis of, okay, pattern of vertical pressure. On the pattern of vertical pressure. ये पूरा अलग है. This is a different way of arranging atmosphere. This is a different way of arranging atmosphere. Okay, so my question to you is, I think all of us know this, that as we go up the mountains, okay, it becomes difficult to breathe. Why? Okay, higher in the mountains, the amount of oxygen becomes less, right? At the sea level, okay, we have more amount of gases. This more gas, less gas is what is called as the atmospheric pressure. So if you have the surface here, okay, this is sea level, okay, I have more atmosphere here. As I go up, the atmosphere becomes less. As I go up, it becomes even more lesser. Okay, but remember, the constant proportion remains the same. The lower gases, I'm just giving a random number. The lower layers, maybe they have 10,000 molecules. You go higher, maybe here, there are only 1,000 molecules. You go higher, there are only 10 molecules. You go higher, maybe 1 molecule. There's a rapid, almost exponential decline of the amount of gases. But if I'm looking within the homosphere, ratio of gas is same. 10,000 molecules, 78% is nitrogen, 21% is oxygen, 0.93 is argon, and 0.03 is carbon dioxide. You come here, same ratio. You come here, same ratio. But the total number of molecules are lesser. So in the vertical pattern, there is a decline of pressure. Okay. What is pressure? If I talk in layman, what's pressure? Pressure is the weight. So here on the sea level, I'm experiencing weight of which layer? If I put a if I put maybe a barometer here, the pressure is what? Is the weight of the atmosphere. Which atmosphere? Which part of the atmosphere? The whole atmosphere. So at the sea level, I have the weight of the complete atmosphere. Correct? At this level, the weight of which layer? The remaining layer. Yahan par we have the weight of only this much layer. Ye hai. At this height, I have the weight of maybe only this much atmosphere. Is it okay, all of you here? Okay, with rising height, the pressure will decrease because as I go above, the amount of atmospheric molecules are reducing. That's why. But my question to you is, why is the pattern like this? Why you have got so much molecule here, but very less molecule here, and very less molecule? Anybody can tell me the answer? Gravity. Okay. That's not wrong, but that's not the best answer. Say if I had some other substance, say मैंने यहाँ पर, say I keep an iron rod here. Will the same pattern of pressure apply on iron rod? Will I say iron rod का यहाँ पर ज़्यादा molecules होगा, यहाँ पर कम molecules होगा, यहाँ पर कम होगा? We can say that? No. And you're right, but one more fact. This pattern is because of two factors. One is air has weight and air is compressible. Correct. So here I have the weight of entire atmosphere, and because of more weight, these layers are more compressed. You come here, okay, यहाँ पर कम air रह गया. इसका weight, so a bit less of compression. So if for example, if there are 1 lakh molecules, because of compression, most molecules are niche. Air has a weight and air is compressible. These two factors together are responsible for why we have this pattern. In case of iron rod, kya ho raha hai? Iron rod has weight, but iron rod is not compressible. The same applies even for water, although there is some differences there, but water also is not as compressible. And that's why we have all the hydrostatic machines that run, because water can't be compressed beyond a point. Okay? So if you look at the atmosphere, I said, on the basis of pattern of vertical pressure, okay, there is a pattern of amount of molecules that decrease rapidly with height. And because there is a pattern of amount of molecules that decrease rapidly with height. Okay. And why this happens, I gave you two reasons. Because air has weight plus air is compressible. Air has weight and air is compressible. Okay, all of you? So what we have is a typical pattern. I'm just giving a couple of figures here. At the sea level, okay, it is the weight of 100% atmosphere. This is the sea level. And we can call this pressure as 1 atmosphere. Is the weight of 1 atmosphere. By the time I reach a height of 5.6 kilometers, ये 0 है. Okay. The atmosphere जो है, only 50% remains. Remain 50 से नीचे हो जाता है. Above it, only 50 remains. So at this point, we have 50% atmosphere. That's equal to half atmosphere. इसके बाद, every 5.6, the pressure falls by half. 5.6, another half. So if we come to around, okay, 11, 12, okay, it becomes, another half becomes, so around say around 11 to 12 kilometers. What's left is, यहाँ पर 75% atmosphere is over. Okay. By the time I come to 16 kilometers, almost 90% is over. So इसके ऊपर में we have only 10% of atmosphere. So 5.6 kilometers में 50% of atmosphere is left above. At 11 to 12 kilometers, only 25% of atmosphere is left above. At 16 kilometers, only 10% of atmosphere is left above. You keep adding, I said approximately 5.6 add करते चले जाओ. जैसे यहाँ पर 75 है, 25 बचता है, उसका आधा रह जाता है आपके पास. So you remember these values more or less. लिखा आपने all of you? At 50%, at 5.6 kilometers, 50% is left. At around 11, 12 kilometers, only 25% of atmosphere is left above. At around 16 kilometers, 10%. And by the time you hit about, say, around 30 kilometers approximately, okay, only less than 1% of atmosphere is left. At 30 kilometers, only 1% of atmosphere is left. Yeah, you can have a table also if you want to have. Sea level. Sea level at 5.6 kilometers, at 11 to 12 kilometers, at 16 kilometers, at more than 30 kilometers. Sea level में it is 100% atmosphere. 5.6 में 50%. By the time you come here, only 25% of atmosphere is left. You come here, okay, only 10% of atmosphere left. Here, less than 1% of atmosphere is left. नहीं अभिजीत लिखो इसको. I will not dictate. इतने पैसे थोड़ी दिए तुमने. लिखो इसको. Draw the same graph. Same thing I wrote here, I repeated there. %25 of atmosphere is left above. 10% of atmosphere is left above. So if I say sea level में, at sea level, the pressure is 1 atmosphere. यहाँ पर कितना pressure होगा? 0.5 atmosphere. यहाँ कितना pressure होगा? Okay, 0.25 atmosphere. यहाँ कितना pressure होगा? 0.1 and so on. 1 atmosphere is equal to, anybody knows? 76 centimeter of mercury column is equal to approximately 1013 millibar pressure. So here I mentioned height above sea level. This is the percentage of atmosphere left above, and this is the atmospheric pressure. Millibars, yes. 1013 millibar pressure. is one of the units of measuring pressure. ये क्या है? 76 centimeter of mercury column. Barometer is in terms of mercury column. Okay, this is mercury of mercury column. Please don't see this as physics and mathematics, okay? It's very basic, not even GS. Okay, very basic okay, information. नहीं पता था तो आज जान लिया और क्या? It's all school level चल रहा है अभी. In one of the previous batches, couple of batches ago, one boy said, so every time you say school level chal raha hai, I get so depressed. Okay, I get so guilty. My answer was good. Okay, you should be guilty about what you did with your school life. Okay, so fine. Now you know things better. Will this be asked directly? Yes, absolutely. Ashutosh, ऐसे ही पूछेगा. Okay. How to use this? आशुतोष अभी बहुत दूर है. अभी जान लेते हैं सैंड एक चीज है. कैसे ब्रिज बनाना है? Wait for that. Just know the facts right now. How to use it comes afterwards. All done with this? So, what does the graph look like then? The graph looks like something like this. This is 1 atmosphere. Somewhere here is a half atmosphere. This will be 5.6 kilometers, 0, and accordingly you can keep on plotting whatever you want to say. So one atmosphere, and it falls very rapidly with height. हाँ, guilt का दो ही होगा consequence. With the guilt, either you will start working harder or you will quit or क्या. Let's not quit right now. It's too early for that. No, don't worry. Abhay, the good news is most of you are this kinds. So there is a long club of people who do not know the basics. No problem. All done with this? The pattern of atmosphere, how it changes. Now you go back to what I said. In the homosphere, heterosphere, I said, for much of the atmosphere is very well mixed. So imagine if about 30 kilometers has almost 99% of atmosphere, beyond 80, how much remains? Almost trace. For much of atmosphere, within 80 kilometers, it's very well mixed. That makes sense now, all of you? Even if the height of atmosphere is as much as 1,000 kilometers, okay, but doesn't mean all the gases are uniformly spread. More and more gases are in the lower heights, and the atmosphere is very well mixed, is churned, is part of one single unified atmosphere. All good? So there are two ways of looking at how the atmosphere is organized. The atmosphere is organized, number one, okay, in terms of relative mixing, and number two, in terms of the pressure patterns in the vertical direction. That's the reason why you go at higher heights, you start having problems of breathing. Okay, you start having nose bleed because there is a pressure of your heart, the blood pressure. The blood pressure is very powerful. Okay, but the atmospheric weight, okay, balances the heart pressure. If the atmospheric weight becomes lesser, the heart can burst your burst vessels. your veins and arteries can burst, your blood vessels. So when you go at higher heights, your nose starts bleeding because of that. One of the most fine layers are in your nose. Yeah, capillaries, yes, so very, very fine. That's why nose bleeding happens first. So for some of them at higher heights, if you do not manage it well, you also have internal bleeding. एक बहुत common problem होता है lungs में हो जाता है. You can't breathe well, so what happens? Lot of fluid from the body starts accumulating inside the lungs itself. वो lungs में push हो जाता है. What people do in the airplanes? Omkar, you must have heard about the aeroplane cabins are pressurized cabins. Okay, there's a lot of pressure inside. वो artificial बनाया जाता है. That's why when you're landing, your ears start popping. Because they slowly reduce the pressure. Then you can hear your ears popping out. ठीक है? कितना पढ़ा दिया यार? Okay. आगे बढ़े? Okay. Now the third scheme of atmospheric structure. Third is on the basis of temperature patterns. On the basis of temperature patterns in the atmosphere. ये सबसे common वाला part है, but I find a lot of people have problems in some of the basic concepts. Yes, correct. Aircraft beyond carbon line does not have enough lift because the atmosphere is very, very rarefied. Correct. Correct. Okay, let's move on. So, first couple of ideas. Say this is the sun. And this is the earth that we have. Earth with its mountains, with its plateaus, elevations, and also oceans, ये earth है. And maybe, say this is your atmosphere. Okay? So these are some layers. This is some layer A. This is some layer B. This is some layer C. And layer D here. The sun rays are coming straight towards the earth. Which layers are closest to the sun? A. Okay? But I hope all of you know this. A is not the warmest one. Okay? Because the energy coming in is having high frequency. Okay? If the energy, say if I have my palm here, I have source of energy. If the energy passes through my palm, I will not feel the heat. Only when the energy gets blocked by my palm and my palm absorbs it, then I will feel the heat. The energy is so powerful, we understand, I think we know these are all short wave radiations. Short wave radiations are very high energy radiations. So when they come towards the earth, they're so powerful, A can't block. Some might be absorbed, but not much for heating. Even B can't block. The atmosphere, okay, is almost transparent to the energy coming from sun. It goes and hits the earth. The earth absorbs all the energy, and then the earth is radiating out. The earth radiates back. When the earth radiates back, the energy is now, okay, a long wave, and the energy is low energy. This is short wave and high energy. It passes straight. Atmosphere cannot absorb it. In some parts it does, but nothing significant. Bulk of the energy reaches the earth, and the earth absorbs it, and the earth again releases the energy. And this energy is a long wave and low energy. Therefore, the lower layers absorb first. So I have got carbon dioxide here, I have got dust particles here, I have got water vapor here. The lower layers absorb first. As I go above, the molecules are lesser. Okay, the molecules will have less of water vapor. They have less of carbon dioxide. They have less of dust particles. As I go higher, there is less and less absorption. That's why the lower layers are more warmer, the upper layers become a bit more cooler. Okay, so this pattern of temperature creates some layers of temperature in the atmosphere. Is it okay, all of you? I think most of you know this. If no, fine, we can revise this. The distance of sun is very high. Why is it called short wave? Short wave is in terms of the wavelength. Okay, this between crest to crest is called as the wavelength. So this is a short wave and this is a long wave. So from this crest to this crest is ज़्यादा distance है. From this to this is less distance. So close packed one, उसका property वही है. Something which has more temperature will give you more shorter waves. There's a relationship between temperature of the body and its relation with the wavelength. इसका inverse relationship होता है. There are laws on this. Stephen Boltzmann law, Wayne's displacement law. You can ignore all of that. You remember right now. Because Earth is far more cooler than the sun and sun is very, very hot. So energy coming from sun is high energy and short wave. Compared to this, the Earth is cooler. Energy coming from Earth is long wave and low energy. The relationship between temperature and the wavelength of the radiations. All fine here? So write down something here, write down. The energy coming from the sun, the energy coming from the sun is high energy shortwave radiations, is high energy and short wave radiations. Okay. The radiation spectrum from the sun is, the radiation spectrum from the sun is यह range of energy coming. Gamma rays, X-rays, ultraviolet rays. This is the visible spectrum. This is infrared. This is microwaves. These are radio waves. This is called as the solar radiation spectrum. All my life I've remembered this as Gaxu-Vimar. Right from my school days, I had this mnemonic with me. Okay, you also remember as Gaxu-Vimar? याद रहेगा कुछ नहीं? ठीक है, Vim याद तो रहेगा. I think most of us know this. Okay, so gamma rays, ये sequence है. Gamma rays, X-rays, ultraviolet, visible spectrum. The visible spectrum can be opened up into the 7 colors. इसके अंदर में there is violet, with your indigo, blue, green, yellow, okay, orange and red. The 7 colors that make up white light. So ultraviolet के बाद में red, violet ही आएगा. And before infrared, I have got red here. याद रहेगा? ठीक है. This sequence is sequence of what? Reducing energy. Gamma rays have the maximum energy. The radio waves have the least energy. This is the sequence of reducing energy. This is a sequence of increasing wavelength. Infrared has more wavelength, okay, than the red. Violet has the least wavelength than the red. So increasing wavelength and decreasing energy. This is decreasing energy sequence and this is increasing a wavelength. Microwave. M is microwave. R is radio waves. Radio waves are the longest waves. Now when the sun emits this, the gamma rays and X-rays, they largely are absorbed by Earth's magnetosphere. I hope you know Earth has a magnetic sphere around it. The magnetosphere absorbs this. ये Earth तक आता ही नहीं है. If it enters Earth, it literally will roast the Earth. It's very, very powerful. So gamma rays and X-rays, okay, they are absorbed by the magnetosphere. Keep writing, please. These are absorbed by the magnetosphere. What enters Earth is largely these. We have ultraviolet coming in, we've got visible spectrum, and some amount of infrared. Okay. This is what enters the Earth. And the incoming radiations, they do not have this. ये बहुत less energy है. Okay. Right, next. Ultraviolet, visible and infrared. Ultraviolet, visible and infrared radiations enter the atmosphere system. They enter the atmosphere system. And there was a question last in prelims on this. Okay. Ultraviolet, this is absorbed by ozone. Keep writing next point. Okay. Ultraviolet radiations are absorbed by ozone layer. Ozone layer in the stratosphere. Ozone layer in the stratosphere. Okay. Within bracket mention that ultraviolet of stratosphere can warm the atmosphere. तो absorb हो रहा है. Ultraviolet of stratosphere can warm the atmosphere. Okay. Visible spectrum. Here we have visible spectrum is not absorbed by atmosphere at all. Is not absorbed by atmosphere at all. We often say that the atmosphere is transparent to the visible spectrum. The atmosphere is transparent to the visible spectrum. Anybody knows iska kya range hai? Anybody knows the range of this wavelength? Yeah. So about microns mein, this is 0.4 microns and this is 4 microns, not 0.4. This is 4 microns and this is 7 microns. So 4 से 7 micron तक, micron is in power -6. Okay. 4 is on the violet side. 7 is towards red side. 4 to 4 microns. Micron ऐसे लिखते हैं. Micron to 7 micron is the visible. इस range में the atmosphere can't absorb. Why? Because that is the property of the atmosphere. We say atmosphere has selective absorption capacity. Okay? इस range में atmosphere is completely transparent. ये घुस जाएगा पूरा अंदर अर्थ तक. So this range is also called as the atmospheric window of radiation. The visible spectrum is also therefore called as the atmospheric window of incoming radiations. Yes. Yeah, that's what I was. Yeah, it is 0.4, not 4. पहले सही बताया फिर गलत हो गया. It is 0.4, correct. Modify कर लो please. 0.4 to 0.7 microns is atmospheric window. Okay, in the visible spectrum, the atmosphere is not heated at all. Remember this. And to mention, the infrared spectrum is also selectively absorbed. The infrared spectrum is also selectively absorbed. Infrared, some oxygen can absorb. Infrared, some water vapor can absorb. So there is some amount of absorption of infrared. And the incoming radiations do not have microwaves and radio waves. All of you fine here? Okay, then write down. So see, GAXU, gamma and X-rays, ये तो है ही नहीं. This is a very, very small amount, gets absorbed by the ozone layer. This is a very big chunk which atmosphere can't absorb, and this is absorbed very selectively by atmosphere. So by and large, we can say for much of atmosphere, the incoming radiations, they do not directly hit the atmosphere. Write down. The atmosphere, therefore, is largely not heated. The atmosphere is therefore largely not heated by incoming radiations. Is not heated by incoming radiations. The atmosphere is heated by the counter radiations from the Earth's surface. The atmosphere is heated by the counter radiations. Counter क्या होता है? And the Earth absorbs, and the Earth is now releasing back. The releasing back is called as the counter radiations. Okay, at a point, the counter radiations are long wave and low energy. They are long wave and low energy radiations. Okay, the counter radiations are absorbed by carbon dioxide, water vapor, dust particles, methane, water vapor, dust particles, methane, and other pollutants. So the warmest layers are near the Earth's surface. So the warmest layers are near the Earth's surface, and the atmosphere becomes cooler with height. And atmosphere becomes cooler with height. Is that fine, all of you? Okay, so what we have is, we have the Earth's surface. Okay, so from the Earth's surface, energy coming in, this will not heat. So I have a graph maybe here. Okay, on this line, I am measuring height. On this line, I am measuring the temperatures. So near the surface, Earth is the warmest. You go with height, it becomes more and more cooler. Okay, and at some point, okay, the Earth again starts to become warm. And then the atmosphere, no, not Earth, atmosphere, it again starts to become, okay, cooler. Okay, there's a pattern in how temperature starts changing with height. Write down. Based on how the temperatures change with height. Based on how the temperatures change with height. There are 4 layers based on temperature patterns. There are 4 layers based on temperature patterns. So I think all of you know this. Lowermost layer is called as the troposphere. Then we have the stratosphere. We have the mesosphere, and the uppermost layers, we call this as the thermosphere. So based on the temperature pattern of atmosphere through height, we have 4 layers of atmosphere. Okay, the stratosphere, where the temperature reduces with height. The stratosphere, the temperature increases with height. Okay, the mesosphere again falls with height, and thermosphere, it again increases with height. लिख लिया आप लोगों ने? The 4 layers of the atmosphere. Fine, that's for today's class. So now all of you, the new and old students know this. The new students, twice or thrice a week for 15 minutes after class gets over, we have a short session for case studies. So case studies are like discussions on some important events, okay, which is taken by Shabbir Sir. We start at 2:15, right? क्या time बताया आपको आज का? 2:15. So wait for a few more minutes. 2:15. It will not take more than 15-20 minutes. Attend that. On different days, we have different type of small activities. It could be PYQ, it could be current affairs. So be patient for 1 week. You'll get a hang of it. Yeah, Vijay. Acha, that's what he told you. Fine. So fine. I think Ajay Sir is taking landforms today in that case. The new students, please sit through on this. You don't need to have geomorphology for this. Landforms of glaciers, landforms of wind erosion, landforms of maybe marine or whatever. Okay? So online students, you can log out. There is another button on your dashboard. You click that button. Okay? You can log in from there. This class ends. Yeah, tomorrow I'll continue with this. Okay. Bye-bye all of you. Bye. Yeah, 2:15 he'll start off. Okay. What landform? I think he has to finish some glacial, and then he might add fluvial or desert, whatever. It's not compulsory. Okay. These are additional sessions. If you can attend, attend, but I will not teach in the regular class. Yes, Pratish, but you don't have to know geomorphology for this. Okay, bye-bye. What's that?
Oscillating theory of mountain formation.
What's that theory?
Oscillating theory.
Oscillating theory. Oscillating theory.
तो पता नहीं मतलब हमारे कॉल करना पहले
Recent theory था.
recent था ना
Oscillating theory क्यों बोल रहे हो?
उसमें like tectonic and oscillating तो आ जाता है oscillating.
But who said oscillating is modern theory?
Like I had a talk with a friend
ये ना
उसको पढ़ाया
उससे पूछो कैसे पढ़ाया गया. Not messed up like this.
after 1945 आया था.
Don't